Alright, question 1 part D. The domain, well, we know that x minus 2 must be greater than 0. We can't put 0 or a negative number into a log, so that gives us x is greater than 2. And that fits with the idea here that we've got a horizontal translation of 2 units to the right. So the domain is just x greater than 2, and the range is again any value of y. Okay, asymptotes and axis intercepts. Well, the vertical asymptote will be where x minus 2 is equal to 0, so that gives us a vertical asymptote at x equals 2. Axis intercepts crosses the x-axis and y is equal to 0, so we want to solve for log x minus 2 minus 2 is equal to 0. That gives us the log to base 5 of x minus 2 is going to be equal to 2. So x minus 2 will be equal to 5 squared. So x minus 2 will be 25. Rearrange and we get x equals 27. Alright, y-axis intercept, well there isn't one because we've translated this to the right 2 units, so it's even further away from the y-axis than the normal log curve, so there's no y-axis intercept. Alright, sketch the graph. First thing we do, sketch in the vertical asymptote at x equals 2. Okay, so it's y equals log to base 5, x minus 2 minus 2, so just roughly a normal log would look like that. This one's got a translation to the right of 2 units and a vertical translation down of minus 2. So it's going to be more like that. So drawing that in over here, now the scale's going to be a bit out here. I'm going to draw it like that. We know here that it crosses the x-axis at 27. Alright, part 4, I'm going to find out where the y value is minus 1, so we've got to solve log to base 5, x minus 2 equals minus 1. So that gives us a log to base 5 of x minus 2 is going to be equal to 1. So that's x minus 2 is going to be equal to 5 to the power 1. So that's going to give us x minus 2 equals 5, or x equals 7. So we've got passing through that point 7 minus 1. And I guess you know, somewhere there. Graph not really drawn to scale in that case. That's the end of part D.